Today's heading is structure of the atmosphere. So go ahead and write that down, structure of the atmosphere, and we're going to go over the 5 layers of the atmosphere today. All right, so structure of the atmosphere. If you picture there, okay. Now, we are starting closest to the Earth and working our way up. Closest to the Earth, like where we're at right now, and working our way up. So the first layer of the atmosphere is the troposphere. Go ahead and write all of this down. The majority of all gases are in the troposphere, and weather takes place here. The majority of all gases are here. Weather takes place here. Now, the reason gases are close to the surface here where we're at, okay, is because they have mass. Gravity is pulling them down. So most gases are close to the surface because they have mass. And in order to have weather, you need gas, okay? So like wind is moving gases. Well, if the gases are close to the surface, so will the weather. Okay, clouds are water vapor and ice particles. Well, those are going to be close to the surface because they have mass. So the troposphere, the very first layer of the atmosphere, you're going to find lots of gases here, and you're going to find weather. Then we have the stratosphere. So the second layer is the stratosphere. Go ahead and write all this down. You're going to find the ozone layer here. Planes can fly in the lower stratosphere. We'll get into the ozone layer on a different day. But the ozone layer is a layer of oxygen, O3, that basically blocks UV radiation from hitting the Earth. Okay, it blocks a bunch of harmful UV rays from the sun from hitting the Earth. And also, planes can fly in the stratosphere. You maybe have seen a movie or maybe you've been on a plane where there's rough weather and they can actually fly above the weather, so it could be storming and you'll be above the rain. If you've been in a plane before, maybe you've if you look out of the window, you can see the clouds below you, so you're above some of those weather factors. So it goes troposphere and then stratosphere. For your test, you're going to need to know these in order, and you're going to need to know significant things about each one. So if I say, where is the ozone layer, you need to know stratosphere. Or I might say stratosphere, what's significant in there? And you'd say it contains the ozone layer, planes can fly here. Planes also fly in the troposphere, but they can fly in the stratosphere. Then we have the mesosphere. The mesosphere is the third one, it's the middle one. Not about a lot of significant things here. By the way, write that bullet down. Other than it's very cold. And as you go up in the atmosphere, there are less and less air molecules. So you couldn't go up to the mesosphere and just hang out there and breathe, okay? You would suffocate. Another thing, you watch movies and you maybe see like there's a plane, there's a fight or something, and someone climbs out on the wing of the plane while it's flying, okay? There's so many things that are wrong with that, but one of the big things is you would suffocate. They pressurize the plane and pump oxygen in it when you're flying, because when you go up to high elevations, there's very little oxygen. So if you're in a plane, you could never just like open your window and hang out, okay, because you would suffocate. So mesosphere, very cold. Then we have the thermosphere/ionosphere. You're going to hear it called either way. Your book kind of lines things up slightly different, but this is how we're going to do it. So thermosphere, or ionosphere. And go ahead and write both bullets. The auroras occur here, and meteors begin to burn up here. The auroras is a fancy way of saying northern lights. Auroras borealis is the northern lights. Auroras australis is the southern lights. Okay? If you remember way back to chapter 2, we talked about ions. Those were atoms with a charge. So if it was negatively charged ion, it had more electrons than it was supposed to. Or if it was positively charged, it had less electrons than it was supposed to. So those were ions. Well, this layer contains tons of ions of different elements that cause the auroras to happen. Okay, radiation from the sun excites these ions and they glow. That's a very simplified version there. Okay, but the northern lights are going to occur here. We don't see them in South Dakota very often. I don't know if anyone's seen them. You can see them really well in Alaska. The closer to the poles you are, the better. Alaska, Canada, northern Minnesota. There are times when you can see them really well there. Okay, so auroras happen. Meteors begin to burn up there. Okay, the cool thing about our atmosphere is it not only protects us from harmful UV rays, but also meteors. Okay, when a meteor gets too close to the Earth's gravity is going to suck it in. Okay, and as that meteor falls through the atmosphere is going to burn it up because of friction with air molecules. Okay, if you've ever rubbed your hands together really hard, okay, if you rub them together really hard and fast, your hands are going to warm up, okay, due to friction. Well, if you have a meteor falling through the atmosphere and it's falling at hundreds of miles per hour, okay, and it hits air molecules, those air molecules are going to create friction, which is going to create heat, which is going to burn up the meteor, okay? So most meteors are going to burn up. If you've seen a shooting star, that's a meteor burning up in the atmosphere, okay? Sometimes they have meteor showers where there's a bunch of small meteors that are falling to Earth and are burning up. If a meteor actually makes it to Earth, like it lands on Earth, it might land as just a small little rock, but it started as a giant meteor and it just kept burning up, and a very small portion of it made it to Earth, okay? So those are significant things with the thermosphere or ionosphere. The final one, exosphere. Go ahead and write this in both bullets. I think of exosphere as you're exiting the atmosphere, your exosphere. Satellites are here and above, and there's no real border between the atmosphere and space. So all our satellites are here. The reason you have DirecTV, okay, is because there's a satellite in the exosphere orbiting Earth, sending signals around the world. The reason a lot of things on your phone work is because of satellites, GPS, a lot of internet-related things. You guys could go look at a picture of your house right now, okay, because of satellites going around the Earth in the exosphere. Also, there's no definitive line where all of a sudden the atmosphere ends and space begins. It just kind of continues to fade. Remember, air molecules are in the troposphere close to the Earth, and then it just keeps getting thinner and thinner until there's no more air molecules. So there's no line of oh, welcome to space or welcome to the atmosphere. It just gradually changes. Why don't we stop there for today?